And Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Dr. Haidar with the student ID 2024-044. And today I would like to present my practical report on the network security practicum, where today I will focus on three critical pillars of my practicum. That is the initial network setup, the implementation of access control list, and the configuration of network address transaction. These three components form the backbone of a secure network perimeter, and I will explain the technical steps we took and the logic behind each configuration. Alright, first the initial topology and the network baseline, where here, before we implementing any security measures, we must establish a functional network baseline. In this practical, we define a clear boundary between the internal trusted network and the external untrusted network. We assign static IP addresses to our gateway and client nodes, and most important part of this stage was performing a connectivity test using the ping command. Why is this baseline critical? In network security, we must ensure that routing is working perfectly before we apply filtering. If we cannot ping a sample at this stage, we know it's a routing issue. Once we confirm connectivity, we can then apply firewall rules. If the ping fails after we apply the rules, we have empirical proof that our firewall is successfully intercepting the traffic. This stage represents the feasibility phase of network security. Next, we move into the implementing basis uh, into the 3.2 access control list, or we can say is ACL. This is where we define the activity of cloud traffic. During the practical, we focus on the standard or an extended ACL concept. We configured rules based on three tuple patch, that is source IP, destination IP, and protocol. The core strategy was the default denial policy. Instead of trying to block every bad thing on the internet, which is impossible, we block everything by default and only whitelist specific trusted traffic. One technical challenge we addressed was rule sequencing. We learned that the firewall processes the ACL table from top to bottom. If we put a permit-all rule at the top, the specific deny rule underneath, it will never be executed. Therefore, we carefully script our ACLs to move from specific rules at the top to general rules at the bottom. This ensures that a specific block host cannot bypass security through a more general permission rule. And then, for proving the ACL configuration, we test the ACL where we got where in here we test three different uh, kind of tests where the results shows to us that the PC0 to server 1, which is ICMP, is got failed status. It proves that our ICMP deny rules, our host ICMP deny rules were within from the PC0 to server 0. It got successfully implemented. And why test from server 0 to PC0 is got successful? Because the rules that we implement is just from PC0 to server 0, uh, not from server 0 to PC0. And also, because it's just from PC0 to server 0, so where you test from another PC, for example, in here we tested from PC1 to server 0, it got successful delivered like that. All right, and then we move into the section 3.4, where in here uh, we got a network address insertion and masquerading. This is perhaps the most practical application of IP tables in modern networking. In this section, we use an NAT table and post routing chain. The primary goal was IP masquerading. Uh, we configure the gateway to act as a representative for the entire internal network. When an internal client sends a packet to the internet, the firewall replaces the private source IP with its own public IP address. Well, technically, uh, we block the port HTTP80 from the PC0 to access the what is it? The IP address of server zero within website. For example, we just moved into the 3.5 that is test TCP, where as you can see in here, PC0 got failed when want to access within the IP address of the server zero, where it shows to us that the got timeout. But if you try it to access the IP address of server zero from the not from another PC, for example, like from PC1, it will show to us the index HTML of the website that been in the been got into the server zero IP address like that. All right, and for the summary, by establishing a baseline, defining strict access identities, and hiding of internal structures through NAT, we have built a multi-layer defense. This step demonstrates that network security is not just about blocking traffic, but about intelligent traffic management. All right, that's all for today's practical report. Thank you for attention.